Okay, welcome. And today we're going to talk about one of my favorite topics, one of my favorite techniques, which is partial fraction decomposition. It is tedious, I'll be honest with you. It does take some time, a lot of algebra, but it works really nicely and allows you to be able to use other techniques with simpler things. And this is more for quotients, as I'm going to get to in a moment. So let's back up for a second. So in this case, we've dealt with situations where we could but we could integrate things like this. Like for example, we know du over u will give us the natural log of the absolute value of u. Oh, excuse me. Plus c. And then we've integrated things like this, where we have a quotient where we have a squared plus u squared, right? So du over this, we get 1 over a inverse tangent of u over a plus c. So we've done this, but we have not introduced anything as far as how to handle general quotients like this. Okay? But if we take something like this where we have a sum, we do know how to deal with this because these are simpler ones, right? So we can deal with 1 over x plus 1 because this becomes just du over u, right? So this becomes the natural log of x plus, the absolute value of x plus 1. And likewise, if we pull the 2 out, make this 2 times 1 over x minus 2, this also has the form of du over u. And so this becomes 2 times the natural log of x, the absolute value of x minus 2. Plus c. So we can deal with the simpler ones, right? But notice something here. If you get a common denominator, right here, so if you get a common denominator here, we get this as x minus 2 over x plus 1, x minus 2, plus 2 times x plus 1 over x plus 1 times x minus 2. Well, look what we get. You get the same expressions we had before. So this is equal to this, which would equal this. So if in this case we take something that we don't know what to do with and we decompose it into a sum of simpler fractions, simpler quotients that we can integrate easily. Okay? And so that's where the method of partial fractions come in, because what we're going to do is we're going to use this method of partial fractions to decompose quotients into sums or differences of simpler quotients that we can then use other techniques, or we recognize how to integrate them, okay, using other techniques, okay, like for example trig substitutions, right? Trigonometric integrals, u substitutions, right? So partial fractions is going to be a technique that we use to basically decompose complicated looking fractions or quotients into sums and differences of simpler quotients that we can more easily integrate using other techniques. Okay? So in the next video I'm going to introduce the idea of partial fractions and how it works. And then we'll go from there. Okay, see you then.